Hello! Welcome to our presentation. We are a team of Hong Gai High School from Vietnam. Now we will introduce about how we deal with organic waste by using silver phosphate.
Nowadays, the amount of organic waste has increased rapidly due to the development of industry. These toxins are put to the lake, river, or the ocean, so that may damage the environment of many creatures. As a consequence, handling organic waste is a serious problem that humans have to deal with. Many methods have been employed for the conversion or the degradation of the toxic chemicals to non-toxic form, such as biological, chemical, mechanical, electrochemical, and photochemical methods. These methods have many different disadvantages and advantages. Biological methods involve enzymes, microorganisms, plants, and algae for the degradation and removal of a variety of organic compounds. However, these methods are difficult to maintain for a long time because biological methods are a waste of time. Besides, silver phosphate shows the strongest antibacterial property on Earth, which has antibacterial properties of silver phosphate and the extremely large surface active area.
Moreover, photocatalysis with many outstanding advantages such as safety, simple process, sustainability, and energy saving is becoming a hot topic of interest to researchers. In there, silver ions have the ability to absorb photogenerated electrons and be reduced to metal on the surface of the material, causing the structure of silver phosphate to be discharged and reduce the activity of optical materials. That's why, in this study, we choose silver phosphate for photocatalytic reactions to deal with organic waste.
The process of creating material silver phosphate to use in this study by crop precipitation method is described as follows. There are 6 steps for preparing silver phosphate materials. Firstly, we prepare the amount of silver nitrate and alkali phosphate. Secondly, silver nitrate and alkali phosphate is dissolved in water. Thirdly, mix 2 solutions slowly and stir it with a magnetic stir for 3 hours at room temperature to produce yellow homogeneous precipitated particles. After that, filter and wash the precipitate several times. The production after filtering is dry out at 100 degrees Celsius to collect the APO 100 samples. Finally, a pure sample continues to be heated at 400 degrees Celsius for 2 hours to collect APO 400 sample. In this way, silver phosphate is successfully produced. The X-ray diffractometer will be used to prove that our result is silver phosphate. Then we capture the surface morphology and determine the particle size by the scanning electron microscope. Finally, we use the Uv Vis spectroscopy to know the sunlight absorbing capability and the speed of decomposing methylene blue with and without silver phosphate.
This is the X-ray diffraction of silver phosphate. According to the X-ray diffraction results, we can see there are 13 peaks at the same position between our sample and silver phosphate's X-ray diffraction data, so that we can conclude that silver phosphate has created successfully. Illustrated in Figure 2 shows scanning electron microscope of silver phosphate material. As we can observe in Figure 2 is the scanning electron microscope images, we can see morphology of silver phosphate particles. These particles have the shape of the sphere. Following our statistics, the diameter of these particles is from 200 to 300 nanometers. This is the graph of the Uv Vis spectrum after analysis. We can see the band gap of our sample is 2.43 eV, which is similar to silver phosphate. However, the band gap energy is the visible light area, so that we can conclude our sample has photocatalyst ability. Figure 4 results in photocatalyst of silver phosphate decompose methylene blue at 20 ppm using sunlight. This graph compares the speed of decomposing methylene blue with and without silver phosphate. We can clearly see that the concentration of methylene blue reduces significantly 90% in 2 hours when using silver phosphate as a photocatalyst material. Meanwhile, we do not use silver phosphate. The concentration of methylene blue reduced is trivial. We can conclude that our silver phosphate sample may have good effects on decomposing organic trash.
In this study, the silver phosphate material were successfully synthesized by a simple co-precipitation method. Observe that the diameter of silver phosphate particle is between 200 nanometer and 300 nanometer. Silver phosphate material show high photocatalytic efficiency. The silver phosphate sample completely decomposes methylene blue at a concentration of 20 ppm after 2 hours of illumination with sunlight.
This is all of our project. Thank you for your attention.